The old saying, time is money, certainly applies to over-the-road hauling. The longer an engine performs at its best without an overhaul, the lower the cost of operation. The key to superior performance and cost savings is using an engine lubricant that prolongs engine life by reducing buildup and wear. Mobil scientists have developed Delvac 1 synthetic commercial engine oil to provide this superior performance. Proven in the laboratory, Mobil Delvac 1 is now being used in the field, and the results are impressive.
What I'm hoping to do is to...
Michael Ragomo, assistant product manager of Mobil's automotive lubricant division, invited engineers from Detroit Diesel, along with Mobil lubricant scientists, to disassemble and inspect a 1995 Series 60 engine, which was driven in commercial use for 900,000 miles.
The engine operated for approximately 400,000 miles on Mobil Delvac 1300 Super extended drain service. The incredible part about the operation of the engine is they operated for a total of 900,000 miles service with the last 500,000 miles on Mobil Delvac 1 without an oil change.
Jamie Spagnoli, senior technologist in the Commercial Engine Oil Development Group at Mobil, oversaw the initial disassembly of the engine.
And we're going to pull the rocker cover off now to look at the valve train assembly. This is key to look at how clean the engine is as far as the sludge buildup, and boy, that is excellent considering the service on this engine. Sludge is a concern, very critical for an oil to keep the sludge dispersed in the oil so that it doesn't deposit on the engine parts, and you could see that Delvac 1 did an extremely good job of keeping that sludge dispersed so it didn't deposit on critical parts of this engine.
We're currently taking off the rocker arm assembly such that we can get into the cylinder head and the camshaft area. We can take a look at the critical valve train components, the most heavily loaded components of the engine.
What we're looking for is any obvious wear, and as you can see, there's really nothing that's jumping out at us. I mean, this cam looks great after 900,000 miles. No wear at all. And after we pull the cam out, we'll look at the bearings that the cam rides on, and that's another key area. This is typical that you get some of the overlay removed. Below the overlay, though, is copper. The key thing is that there's no copper exposure. But these look fantastic for that type of mileage service. What we're looking at here are the piston liners, and none of the crosshatch looks removed, no polishing, no scratching. Excellent shape considering the miles. Take a look at the oil pickup screen. Got some oil covering the holes, but no indications of any sludge at all. Screen looks great.
Ordinary mineral oil can lead to significant deposits, inhibiting piston function, deposits that will rob power and reduce engine life. The condition of the pistons is a good indication of Delvac 1's outstanding detergency and oxidation stability.
Piston looks good. The deposits are typical of what we would expect to see. I mean, the rings are still very free of movement. There's still plenty of chrome remaining on the rings. I'd say they look very good. Looking for any copper exposure. There's still plenty of life left to them, and definitely could have got continued service out of these bearings after 900,000 miles.
After the initial teardown of the engine, the parts were carefully scrutinized by a team of experts from Detroit Diesel. Lee Linville, component manager for the Series 60 product engineering group, and Dan Larkin, fields and lubricants chemist, commented on their findings.
Liners were virtually nil in polish. In mineral oils at much more conservative drains, we see sometimes as high as 10% liner polishing.
The injector bushings are steel bushings, and they are in very good condition. There's no galling whatsoever. on any of the rocker shaft bushing, injector bushings.
I am pleasantly surprised at the condition of the injector adjustment screw buttons. They're in excellent shape. There's not a single one. I talk about a cat's eye formation, a fretting wear condition. None of those show that condition at all, and which is very good.
From time to time with the Series 60, previous to us returning to a Teelan-House micro finish on the exhaust lobes, we saw some skidding between the exhaust roller and the exhaust lobe just after peak lift. None of that is present on this engine. There's no skidding whatsoever, so the camshaft is overall in very good condition.
I believe this camshaft could be put back in the engine for continued service. I think overall the engines that we've looked at with Delvac 1 have probably been some of the best relative to sludge control and lowest relative to piston deposits. As I said, you know, the Crown Land, which typically will run 50%, we're running in a 20 to 30% range in this engine. You know, the rocker cover here is virtually like new here. There's no accumulation whatsoever. It's very clean. That's a very strong point for Delvac 1.
And it's a very strong point for you if you want to save time and money in your fleet operation. Mobil Delvac 1.
Green again in Indianapolis. And there it is. Another Penske car heading into the record book. 2.5 miles to go.
To win at Indy, you have to have a team effort.
Roger Penske's assessment of his man, Emerson is tough, hard, and doesn't make mistakes.
It doesn't matter if you're competing on the track or in the marketplace. If you want to win, you have to pick your team with great care.
14 miles an hour, the fastest lap thus far.
When you think about Penske racing, it's experience, it's dedication, and it's passion to win.
Being the best is something Roger Penske has carried from the racetrack to the boardroom. When he's not working on adding to his record 9 Indy titles, Roger is in the driver's seat for Detroit Diesel, where he's helped develop perhaps the finest diesel engine available today.
I think when people ask me the question, what differentiates Detroit Diesel from the competition, I say one thing, it's our people. They're committed. We put a team together here over the last 5 years that wants to win, wants to build the best product, and maintain worldwide leadership in everything we do. The Detroit Diesel Corporation product line today covers many markets: industrial, marine, generator set, military, and our primary product, of course, is our Series 60 DDC all-electronic truck engine. This engine has taken our company from 3% of the truck market to over 26 in 1993. We think it's the finest engine in the world today. It has the best fuel economy, best emissions, and overall, we think the overhaul life is going to reach 1 million miles. One of the things that's helped us look at this longer life is the use of Mobil's product, Delvac 1300 Super. We think in combination with the Detroit Diesel engine and Mobil products, we can make this game and get to that million-mile race. Together with Mobil in partnership, we think technically we have the very best team. At Hertz Penske, we have a variety of fleets. We have gasoline-powered 10-foot one-way trucks, and we have Michigan trains, which carry over 160,000 pound gross.
No one understands a fleet's need to save money better than Roger Penske. That's why he includes a valuable business tip with every new Detroit Diesel Series 60 engine. Use Delvac 1300 Super.
Mobil Delvac 1300 Super is the oil that we've picked for our entire fleet. It gives us the versatility of carrying one product, yet we can use it across the entire product line we offer our customers in our leasing business. When you have 62,000 vehicles, oil changes become a very significant variable cost in doing business. Delvac 1300 Super gives us the ability to have fewer oil changes, and of course that reduces labor. The Delvac 1300 Super also is key to us in fuel economy. With the engine running clean and free, we see better fuel economy in all our major fleets, whether it's a gasoline-powered engine or a heavy-duty diesel or a mid-range diesel, using the Mobil Delvac 1300 Super. Environmental issues are very key to us in the truck leasing business. I'm sure it's the same for many other heavy-duty truck fleets across the country. What do we do with our used oil? By using Mobil Delvac 1300 Super, this gives us the ability to have fewer oil changes in all our truck fleets. Thus, we have less of a problem in disposing of our used oil. Certainly in partnership with Mobil, using their product, we think this is a real good thing for our company and the country.
Here comes Fittipaldi, Emerson Fittipaldi. The final turn for home, the checker flag, and Emerson Fittipaldi has won his second Indianapolis 500.
Together with Mobil in partnership, we think technically we have the very best team.
The high-tech car is here. Today's engines have up-to-the-minute advances that squeeze more horses out of every cubic inch. But they don't come cheap. The average new model costs more than $12,000. With that kind of cash on the line, car care is a big consumer concern. Smart owners know oil is the lifeblood of the engine, so they're watching what goes in the crankcase, and they're willing to pay for the best. After all, nothing could be too good for that expensive machine. That's why synthetic motor oils, greases, gear oil, and automatic transmission fluid are important to any line of retail auto parts. They're the best you can buy for any vehicle at any price. And Mobil is the pioneer of synthetic technology. Conventional lubricants are extracted from crude oil. Synthetics are built in the lab to exacting standards. They can be tailored to meet any need. The first synthetics were developed for harsh aircraft conditions. Jet engines run so hot, a conventional lubricant would burn up in no time. But a synthetic can take the heat in stride.
It has the ability to resist temperature for long periods of time, much longer than a mineral oil or conventional refined oil.
Advanced technology is why synthetics always outperform conventional lubricants. Oil-based lubricants still have impurities even after extensive refining. These impurities limit their performance. For example, when it's cold, regular motor oils are as slow as molasses. That can wreck an engine.
The wax in a conventional mineral oil will make your oil turn very thick or solid at low temperature.
This oil, cooled to minus 35 degrees Fahrenheit, doesn't even pour. And if it can't pour, it can't flow to critical engine parts. That's why the most wear and tear occurs when an engine's first started, especially in the winter. Regular greases don't fare any better. At minus 35 degrees, this grease won't even come out of the grease gun. At that temperature, you can be sure the grease won't lubricate the parts it's supposed to protect. But synthetics meet the challenge. Synthetic oils pour freely at minus 35, and that makes a difference when Jack Frost does his worst. Synthetic greases also come through. You can count on them even when conventional lubes are solid. Heat is also a problem. Smaller, high-tech engines run at brutally high temperatures, and that's tough on mineral oils. They just can't take the heat, and the engine suffers.
A conventional oil, upon encountering high temperatures, will degrade, form deposits, which in turn can damage your engine.
Synthetics shine at high temperatures. In comparison tests, a V8 engine is run at full throttle with a heavy load. The oil is kept at a steady 300 degrees Fahrenheit. Both oils can handle the heat for 64 hours, but the synthetic goes for twice as long with no problem. And in another comparison test, a 4-cylinder engine is run through simulated city and highway driving for 16 days. In both tests, the results are nothing short of amazing with the synthetics. After the test, the engine run with regular oil is filthy and wear is obvious. The engine parts run with synthetic oil are sparkling. They can be wiped clean with a towel. And there's virtually no wear, even after all that abuse. And synthetics are a lot cleaner than conventional lubricants. While regular oils break down, leaving deposits in the engine, synthetics stay clean. The side-by-side comparisons tell the story. These turbochargers were run for 25,000 miles, one with a conventional oil, the other with a synthetic. The ports on the oil-lubed turbo are plugged with dirty deposits, a sure route to a hefty repair bill. The synthetic lube turbo looks new.
The synthetic lubricant itself holds these undesirable components in suspension. It keeps them from being deposited on the engine.
Synthetic greases are just as impressive. One of these bearing sets was packed with a synthetic grease. One was packed with a high-quality conventional grease. At 400 degrees, the differences are glaring. The conventional grease can't handle the heat. It turns to liquid and runs from the bearing. If this bearing were in a real car, it would seize in no time. Meanwhile, the synthetic grease holds its own.
If you do a lot of city driving, frequently braking, you build up extreme temperatures, certainly higher than the 400 degrees. And the synthetic would not lead to damage of your wheel bearings because it did not melt in this test and it would not melt in your own private car.
The bottom line is top protection and performance. That's why winning auto racing teams use synthetics, the same products consumers can buy.
When you hit the key, it gets to the wearing parts, the moving parts, quicker than any other oil, and that's the big secret.
More power, better mileage. Synthetics offer the performance and protection consumers are looking for today. Demand for them is building, and the Mobil name makes the sale.
Well, of course, with the Mobil product and the Mobil One being the brand recognized in the synthetic market, you have a built-in advantage. The customers come in, they know the product, they're well acquainted with the product, it sells itself.
And Mobil synthetics make good business sense.
On a Mobil One, your profit margin is greater.
Superior performance, superior protection, superior margins of profit. Mobil synthetic lubricants offer benefits all around, backed by the Mobil name, a name you and your customers can trust as the best. Mobil Synthetics, for those who demand the ultimate in driving performance.
The world turns on a thin film of lubrication. When that micro-thin sheet of oil thickens or oxidizes, gears and bearings burn out, production lines go down, and delivery schedules go out of control.
I see synthetic oil getting a much broader application, much broader use. I think the day is coming where synthetics should be sold for the total benefit package they can bring.
That is a Mobil field engineer talking about synthetics, which were developed more than 20 years ago. How long does it take for tomorrow to arrive?
Basically, when we test a unit with conventional lubricant, we will see a 70% efficiency displayed on this console. By applying synthetic lubricant to the very same reducer, we will see the efficiency increase to the area of 77 to 80%.
The design engineer talks about efficiency, but management has to translate that word into power savings or labor savings.
Throughout the whole system, we had two different lubricants, one for winter use and one for summer use, and one oil wouldn't take care of both temperature patterns. So Mobil came along with some synthetics, and we tried them, and we found we've been running about a year, and we haven't had to change oil for summer and winter use.
The best salesperson for a synthetic is a difficult location, a cruel climate, a critical piece of equipment, or a new demand for productivity.
We switched to the synthetic lubricants, and we were getting approximately 3 years of life as opposed to 3 months. In reality, our breakdown rate on typical equipment went down. It's very difficult to say it went down because of the oil, but the oil was certainly a plus, and we feel it was a step in the right direction. We have only seen positive results.
We have also seen the results of power-saving tests over and over again. But how long will it take to prove that better lubrication can actually cut the spiraling cost of electricity and energy?
Our energy costs have gone up, I think, 100% in the last 10 years, and we're confident that we will be able to receive an $80,000 per year savings through the application of synthetic lubricants.
Synthetic hydrocarbons cost 3 times more per gallon, per barrel, than conventional mineral oils. How do you justify the cost? Can it be listed under production insurance, or customer insurance, or job insurance? Is the real justification in equipment life, or power savings, or net savings because of extended oil drains? Before we go one frame, one scene, 1 second longer, we'll make one condition. If we can't save you money, we don't deserve your business. And you don't have to listen to us, but you should listen to our customers. One of them built a power plant on the edge of a vast field of lignite, a 40-year supply of energy. But each ton of coal carries 1/3 of a ton of water, which has to be driven off as steam, water vapor streaking the North Dakota sky.
We're at Coal Creek Station right now in Underwood, North Dakota. This is where our coal is brought in from the mine. We have a series of 6 feeders bringing the coal into our system where we can begin feeding coal over into the 16 different pulverizers that we have, 8 for each unit.
The coal is fed into the pulverizer up here at A, comes down through and into the grinding area. The grinding takes place between these rolls labeled C and the grinding table B. The area between B and D is a hot air area, approximately 750 degrees Fahrenheit. That temperature was breaking down the mineral oils that were being used, and we were seeing very rapid bearing failures.
We were using a regular mineral oil on our pulverizer bearings. They sit below that table inside that rotates where the coal is actually pulverized. And we were finding that we couldn't run much more than a week, maybe a week and a half before a bearing would fail.
We were seeing cases where we had 3 and 4 of these down at the same time, and power generation replacement costs are very high, and we were looking at sometimes hundreds of thousands of dollars a day as the figures that you can use for those replacement costs.
And we've since converted those areas where the bearings are over to a synthetic oil, and have not had any failures since.
We went to the synthetic oil to buy time, essentially. In buying time, we found that there were other benefits to the oil, such as reduced wear, reduced frequency of change-out, reduced labor costs associated with that change-out, things of that nature, which have been a real benefit to us.
Design engineers are beginning to use Mobil synthetic hydrocarbons in a totally different context. They're less interested in fighting downtime and catastrophic failure, more interested in fighting for a share of market.
Our initial introduction to synthetic lubricant occurred in devices that could be used on worm gear speed reducers to increase the thermal horsepower rating of the units. The three devices that we considered as components to increase the thermal horsepower were the fan, the heat sink, and synthetic lube. We became aware that the synthetic lubricant could actually act as a component in the gear.
Underline the word component. The lubricant itself can equal or replace a mechanical component.
For example, a user who has a 2-horse application, a given size unit may have a basic thermal rating with a conventional lubricant of 1 3/4 horsepower. With the addition of synthetic lubricant, because of the increase in efficiency and the reduction of heat that's generated, that same reducer could possibly be used in a 2-horsepower application, giving us a competitive edge in the market by being able to sell him a much smaller unit at a much lesser cost. The cost analysis that we did on these three components indicated that the synthetic lube was the most cost-effective component of the three. A fan package for a worm gear speed reducer will cost approximately $30. A heat sink will be an additional $15. Using a synthetic lubricant, he may see an end cost of $7.50 to $10 maximum.
The cost of money, the spiraling rise of interest, puts new pressures on old equipment. Management needs greater productivity to protect a thinning margin of profit. That means more speed, more heat, and too often, more breakdowns.
A little over a year ago, Champion International Paper Mill made some modifications to one of their paper machines to improve the output of the paper. One of the consequences was to increase the temperature of the bearings that support these rolls. But the conventional oil that was in the bearings just couldn't do the job. It was under too much stress.
We started losing a few felt roll bearings, and the oil temperature went up in some instances as high as 200 degrees. And we had 5 catastrophic failures in a period of 5 days. All 5 were involved a pocket mint roll, a bearing locking up.
Bill Edwards called me and indicated that he knew that he was approaching trouble. In fact, within a span of 13 days, they had lost 5 bearings. Each bearing cost probably 2.5 hours of downtime plus labor to get repaired.
The machine had to go down 5 times in approximately 13 days to either remove a felt to alleviate the need for this roll, or to give us time to install a new bearing on the roll. And at that time, we determined that we would try synthetic product in them because of the increased amount of heat.
Well, Bill recognized that his conventional lubricant was under too much stress. He developed the data that was necessary for the input in the EHL formulas and called me late one evening advising me of the problem that they were having in the bearings.
I made the calculations one afternoon after work around 6 o'clock and contacted the Mobil oil engineer in this area and confirmed the calculations with him.
And the only product that he found fit the needs to eliminate or minimize the metal-to-metal contact in the bearing was one of our synthesized products, SHC 634.
He had the oil sent here the next day at 7 o'clock. And by 11 o'clock, we had changed the oil in all of the felt rolls that were associated with the pocket mint system.
It's been approximately 13 to 14 months since the product was installed, and during